Okay, I wanted to start with number 20 on page 469. When you are trying to set up your proportion, of course we're going to start here with two ratios, and I'm going to use the name of the similarity statement. So I'm just going to start with the triangle on the left, and I'm just going to start with side MP. MP, the first and last letter, corresponds with XZ, the first and last letter in the other triangle. So I'm going to ratio M, oops, let me back up before I plug in. I'm going to ratio MP with XZ, and I'll plug in just a second. The second one I'm given is PN. So side length PN would be the middle and the last letter. It corresponds to YZ in the other triangle, YZ. Now I'm going to go ahead and substitute in, making sure I have the right sides. So I have X plus 5 over XZ is 30. And then I have 4x minus 10 over 75. So now when I set this up and cross multiply, I'm going to be doing 75 times x plus 5 equals 30 times 4x minus 10. Distributing in, I have 75 plus 375 is equal to 120x minus 300. So when I solve here, I'm going to, oops, backing up, that was 75x. I'm going to take away 75x from both sides. So when I do that, that's going to give me 45x. And then I'm going to plus 300 on both sides. That's going to give me 675. And when I divide both sides by 45, I end up with x equaling 15. So you set up your proportions by looking at the similarity statement. The question I wanted to go over was number 26. So number 26 has three parts to it. And we can try to go with a picture. I'll do my best to draw a picture. It says a stage set consists of a painted backdrop with some wooden flats in the front of it. So I'm going to maybe just draw myself like a big stage right here. That's going to be my stage. And so I've got wooden flats on the front. So I'm maybe going to just like put an F by there for wooden flats. And then one of the flats shows a tree that has a similarity ratio of a half to an actual tree. To give an illusion of distance, the backdrop includes a small painted tree that has a similarity ratio of 1 to 10. So we've got, I'm going to also do this. I'm going to call this the backdrop. So we've got one of the flats in the front here. It is showing a tree. I'm going to draw myself a nice little tree here. It is showing a tree with a ratio of 1/2. So I'm going to label this ratio. It is a ratio of 1/2 to the actual tree. So this would be the flat to actual. And then of course I have this, actual tree out here. So it has this similarity ratio. To go on a little further, to give an illusion of distance, the backdrop includes a small painted tree. So I have this even smaller tree here that has a similarity ratio of 1/10. And so that would be the ratio of the backdrop. So I'm going to say that's backdrop to flat. So that gives us a little sense of what the 1 and the 10 represent, and then the 1 and the 2 represent. So part A here, the tree on the backdrop is 0.9 feet tall. What's the height of the tree on the flat? So if I've got the back, if I'm going to work with the backdrop and then the flat, I'm going to work with this 1 to 10 ratio. So I can say here that 1 to 10 is equal to, if 1 represents the backdrop, that's where I'm going to plug in my 0.9. The 10 represents the flat. I don't have that. And when I cross multiply here, I get x is equal to 9. Of course, my unit is feet. So part B is asking us the height of the actual tree. And the second ratio here is flat to actual. So I've got 1/2 equals, do I know the height of the tree on the flat? Well, that's what I just calculated. So there's my 9 over my, this time is x. And when I cross multiply, I get x equals 18 feet. And then part C is saying, what's the similarity ratio of the tree on the backdrop to actual? Well, the backdrop tree was given to me in the problem here as 0.9. So 0.9, I'm writing just a simple ratio here. And then the actual tree I calculated was 18. Well, I want to turn that into a usable fraction. So if I multiply the top and bottom by 10, when I multiply the top by 10, that moves the decimal over. And then when I multiply 18 by 10, I get 180. And then when I reduce that down, that gives me 1 over 20. So you could set up proportions, or you could just determine sometimes I multiply by 10, sometimes I multiply by 2. Okay, one more target, and that was number 28. I'm just going to cross 29 out here. If I've got triangle CGL similar to MPS, the similarity ratio of CGL to MPS is 5 halves. What's the length of PS? So I'm going to start out by writing out 5 halves, and then kind of over to the side here, the 5 goes with the CGL, and then the 2 goes with the MPS, and that's simply because of this part right here. So I know I have 5 halves equals, so the 5, the numerator, has to go with triangle CGL. So when I look at CGL, well, actually, I'm going to go one step further. If I need to find the length of PS, PS is out of MPS, so I don't know that length. But I do know that PS, the second and third letter, corresponds to GL, the second and third letter, which is this side. So I know I have to put my 20 in the numerator to go with CGL. So when I cross multiply here, I have 5x equals 40, so therefore x is equal to 8. So that gives me letter F as my solution. So hopefully that makes some sense. I won't be in class on Monday to go over some of these. So if you have any further questions, you can get on my website and submit the form on the first page in email, or try to ask your classmates and see if anyone else maybe can help.